All right, lesson 3, we're going to talk specifically about those organisms that live in the soil. And so we've talked about those. The most common one you've probably seen are earthworms, but there's a lot of others that you really can't see. So the soil biota, it's basically what lives in the soil. That includes plants living and growing in the soil. Most you really can't see with the naked eye. You have to use a microscope to see this. They're bacteria and fungi. Insects and other animals are part of the soil fauna. So, soil fauna is the microscopic and macroscopic animals in soil. So, bacteria and fungi are the biota and not the fauna because they are not animals. If you know anything about like flora means plants, fauna means animal, that's what that is coming from. So, many organisms that live in the soil are beneficial. Not all of them are. Sometimes fungi can cause infections. Many bacteria are good for plant health, but some are not. So you probably heard of like listeria. They had a big incident with bluebell a couple years ago, and E. coli that's associated with beef sometimes. These could be spread through contaminated soil. This is also why you really need to wash your vegetables, when you get them from the store. In addition, increasingly soil samples are showing evidence of antibiotic resistant bacteria. So these bacteria cannot be killed with most antibiotics on the market. So they could pose a really huge risk to people and animals. So in just 1 teaspoon of ag soil, there can be 100 million to 1 billion bacteria, 6 to 9 feet of fungal strands put in an end, several thousand flagellates and amoeba, 1 to several hundred psyllids, hundreds of nematodes, up to 100 tiny soil insects, and 5 or more earthworms. That is crazy in a teaspoon of soil. That's how live it is. So some plants have natural resistance to this harmful bacteria. Others that's what soil scientists and plant scientists are working on to make them resistant. So grouping soil organisms. So this is how they're grouped: macrofauna, mesofauna, and micro. Macro are earthworms. They're in centimeters, so these are the ones that you can see. You can see a little bit. Mesofauna, they become harder to see with the naked eye. Mites and small insects, they're in millimeters. And then you will not see these with the naked eye. You need a microscope. For microfauna, they're protozoa measured in nanometers, which is insanely small. So there's a grub worm. They're an example of macrofauna. Macro is the bigger. So they make up the living portion of organic matter. You can't just add them to your garden. They have to live in the soil or in the organic matter you add to the soil. So increasing organic matter increases number of organisms living in there. You can't control the type of organic matter added to the soil, and through that, the organisms have to thrive. So sometimes the totality of the soil and soil habitat is called the pedosphere. So pedosphere is the outermost part of Earth where soil forms. So there's a good little food web of soil and everything that lives in it and comes out of it. So you've got your organic matter below your plants, you've got your bacteria with them, nematodes, protozoa, plants, and then it just kind of shows what animals are going to go off of those and survive off of those. So soil science is growing and changing. Some recent trends are transdisciplinary approaches that link soil science with other fields and make soil science accessible for the opportunity to help individuals learn about it. So like soil scientists researching the soil biota might work with biologists researching antibiotic-resistant bacteria. Effective soil management, so figuring out how to monitor and control the soil biota, making sure that soil is staying fertile and retaining water, and sustainable development goals. So, especially in the developing world, sustainable development goals seek to combine economic development for the well-being of the population with environmental sustainability. So like soil scientists and plant scientists work together to increase fertility of soil in a region without causing damage from runoffs and fertilizers.